Hello students, welcome to chemistry classes. So today we are going to discuss one new lesson from inorganic chemistry, that is the S block elements. S block elements, what are the elements present in the S block elements? So I already told you the elements are arranged in the particular manner and it is classified into 4 types: S block, P block, D block and the F block elements. The valence electrons enter into the S orbitals are referred to as S block elements. S orbital can accommodate only 2 electrons. Therefore, the S block elements consist of only 2 groups, the group 1 elements and the group 2 elements. The group 1 elements are called alkali metals. Group 2 elements are called alkaline earth metals because the electrons enter into ns1 orbital and ns2 orbitals. Therefore, they have the name generally S block elements. First of all, what are the elements present in the S block elements? So I already told you the group 1 consists of lithium, sodium, potassium, rubidium, cesium and francium. Group 2 consists of beryllium, magnesium, calcium, strontium, barium and radium. So these are the elements present in the S block elements, that is group 1 elements and group 2 elements. So first of all, group 1 elements. Group 1 elements are called alkali metals. Alkali metals: lithium, sodium, potassium, rubidium, cesium and francium. So alkali means plant gases. The plant gases majorly consist of majority of these elements. From the plant gases, they are exist in the form of hydroxide, sodium hydroxide, potassium hydroxide form. Therefore, they are referred to as alkali metals. Alkali metals. And sodium and potassium are relatively abundant present in the earth crust. And lithium and rubidium and cesium are relatively rare abundant in the earth crust. Francium is a radioactive element. Francium is a radioactive element and its isotope francium 223. Francium 223 is a stable isotope of francium and its half-life period is 21 minutes. Half-life period of stable isotope of this francium is 21 minutes. So these are the elements and their abundance. And the group 2 consists of beryllium, magnesium, calcium, strontium, barium and radium. Here also beryllium is very rare and elements present in the earth crust. Magnesium, calcium are majorly present are abundant in the earth crust. Beryl, magnesium and calcium. Here also the radium is a radioactive core. Radium is a radioactive element and from the radioactive core of radium, other radioactive elements are synthesized in future days. Okay. So these are the groups. What are the nature of groups and what are the elements present in the S block elements? And the general electronic configuration, we know that lithium atomic number 3, 1s2, 2s1. So the generally ns1 is a general electronic configuration of this alkali metals. Alkaline earth metals, we look at the beryllium atomic number 4, 1s2, 2s2. The valence shell consists of 2s2 as the configuration. Therefore, all the elements shows the general electronic configuration of ns2. And the elements present in the groups lithium, beryllium, magnesium and other elements, lithium, sodium, potassium, rubidium, cesium, francium are present in the same group and which mostly shows the similar characteristic properties. The elements in the group show similar physical and chemical properties. The first member of the element, first member of the group 1, that is the lithium, and here also the beryllium shows entirely different characteristic properties of the rest of the family members. So, this property is called cognivous. This property, the first elements entirely differ from the characteristic properties of the rest of the family members. This term is, or they are referred to as cognivous. So, cognivous means is relatively differ in their characteristic properties of rest of the family members. And the first elements of each group diagonally related with other elements or other group elements, that is called diagonal relationship. Diagonal relationship, lithium source, lithium diagonally related to magnesium, lithium diagonally related with magnesium, beryllium diagonally related with aluminum, beryllium diagonally related with aluminum, and also boron diagonally related with silicon. This is a diagonal relationship. Lithium group number 1, this is diagonally related with magnesium of group number 2. So, these two elements shows entirely similar characteristic properties. These two elements shows, or the pair of elements in the diagonal pair of elements shows diagonal relationship, they show similar characteristic properties. Why these elements shows similar characteristic properties or it shows diagonal relationship? This is due to smaller size, both of having almost similar size, and they shows high ionization energy and electron affinity, high polarizing power. So, these are the three reasons: similar size, high ionization energy and electron affinity, high polarizing power. So, because of these reasons, these elements shows diagonal relationship, and they are exist in the form of ions, monovalent ions. So, in the case of alkali metals, only one electron present in the valence shell. Suppose this metal atom lost one electron from their valence shell, it shows Li plus, lithium plus, Na plus, sodium, potassium plus, rubidium plus, cesium plus. So, it exists in the form of monovalent ions. Similarly, beryllium 2 plus, magnesium 2 plus, calcium 2 plus, strontium 2 plus, barium 2 plus, etc. These are exist in the form of divalent ions. Divalent ions. So, this is all about the introduction part of this S block elements. So, under this module we learn about what are S block elements, what are the two groups are present in the S block. Second group is called alkaline earth metals. The group 2 is called alkaline earth metals. Alkaline earth metals, here also form this hydroxide with alkali hydroxide, magnesium hydroxide, calcium hydroxide, etc. They are alkali basic solutions. Therefore, it is referred to as alkaline earth metals. And what are the salient features of this group? Abundance of this group members and diagonal relationship. What are the various elements shows the diagonal relationships. So, if you have any doubts, you may ask. Thank you.